Hi everyone, thank you for joining our fireside chat. Today we will focus on real-time and security in a very challenging automotive industry. My name is Bertrand Boisseau. I'm in charge of the automotive sector for Canonical, and this is Eduardo. Eduardo, hi.
Hi everyone, I'm Eduardo, product manager at Canonical for Realtime Linux.
Thank you for joining. So we want to study today the different security challenges that the automotive industry is facing, if there are solutions to these challenges, and also if low latency in real time can be key solutions to some use cases.
Right. So these days there's a lot of talking in the market about software-defined vehicles and the difference that this is bringing to the automotive sector. What are the major trends you see here? What do we mean by software-defined everything?
Right. So indeed, today one of the key trends in the automotive sector is the software-defined vehicle. When you look at modern vehicle today, you think, oh, it's a computer on wheels.
Right.
Actually, there are tons of computers on four wheels. So this is a highly complex electrical and electronical architecture that you need to maintain, that you need to guarantee the interfaces are working correctly, they need to update. So it's highly complex. And when you think of a component, there's not only the hardware part of things, there's also the software part of things, right? So basically what you want to do is simplify as much as possible the hardware constraints,
right,
and abstract what can be abstracted from a software point of view. So this is basically one of the biggest challenge today. And historically, you wanted to add a feature to a vehicle, to a new generation of vehicles. In this case,
like a software feature.
Exactly. In this case, you're going to add a new software brick, right? The issue is that you weren't able to reuse that brick from vehicle to vehicle and from generation to generation. So you basically started from scratch again. So you can do that when you have 10 features, but once you start having 100 features,
it doesn't scale.
It doesn't scale. Exactly. So that's also the purpose and the real value of software-defined vehicles.
Right. The full embrace of software in vehicles brings with itself a series of challenges and constraints or requirements, right? What would you say are the key considerations or challenges in automotive that one needs to keep their eyes on?
So when you consider software-defined vehicles, not only do you need to guarantee the APIization of the vehicle, so you want to make sure that you abstract as much as possible software.
For the reusability.
For the reusability, and in parallel that you reduce this number of hardware components, because at some point it's just not maintainable, right? It's not one feature equals one additional component.
Like at scale,
yes, you need to make sure that you can scale it correctly. On the other hand, you have very specific constraints due to the fact that lives are at stake. So for example, all the safety surrounding the vehicle and inside the vehicle.
Inside and outside.
Absolutely. It adds a lot of complexity to whatever you want to build.
So safety is one of the key themes.
I would say it's the key challenge. That being said, your system needs to be secure, right, altogether. You don't want a vehicle to be hacked, whether it's an autonomous vehicle or not.
Right.
You want to have access to the brakes, to the engine correctly, right? So it's very critical when you consider it as a whole system. Obviously, there are other industries that have security issues or safety issues, but the closest one that we use every day is the vehicle.
Automotive in itself brings a series of challenges, right, for the sector, and at Canonical we take a vertical first approach to automotive. It's front and center in our product roadmaps and decisions, right?
Right. We want to make sure that we take into account the specificities of the different use cases, right? You wouldn't design a robot the same way you would design a vehicle or a drone.
Each brings its own set of requirements.
Absolutely. But we do believe that there is, at a certain level, a common platform that we can use and reuse so that all of these different sectors can benefit from the new security patches or the new low layer features.
A secure underlying framework that works in industrial vertical. All the lessons learned there about security can sometimes be used in other verticals.
Absolutely. Yes.
Right.
Yes. So I saw that you brought some demos, Eduardo. Do you want to show us?
Let me show you.
All right, let's go. So Eduardo, what exactly does this demo do?
Well, this demo is essentially about face recognition. You can see that there is a green contour, a green box drawn around my face. So the demo, the camera is recognizing my face.
Okay, so I mean, I can definitely see a lot of use cases in the automotive industry.
Like which ones?
So for example, you want your vehicle to recognize your face to make sure that it automatically loads your favorite playlist or song, or sets your AC system and the sport mode, whatever you prefer.
Or like customizing based on your user preferences. I see.
Exactly, but there are also more, I would say, trickier use cases.
For instance?
So for example, you could recognize the facial biometrical data of the driver in order to pay for services.
Or I see like a ID identification of the driver themselves. But I would imagine, especially you mentioned biometric data, this is probably a sensitive topic when it comes to security, right?
Absolutely. I mean, the risks could go from hacking in order to access to your private data, using it for payment, but also for identity theft. So it's definitely something that you want to keep it secure, right? You want it to make it tamper-proof, I would say.
I understand. So it will be important that the application, in this case, the value proposition of a vendor, like face recognition application for automotive use cases, itself is in a secure environment.
Right. Absolutely. So I think that you also brought a second demo.
Yes, so let me show you the second demo. So here you can see another application, somewhat similar to the first one, but now we have a higher level of granularity. So not only you can recognize my face and you can see the blue box around it, but in this case we have a deeper understanding of my facial features, and you can see the contour being drawn around, for instance, my eyes. So I could imagine it is tracking the movements of different parts of my face, and especially in automotive with the driver, I would imagine this comes in very handy, right? Can you think of any scenarios when this may be applicable?
Absolutely. So driver awareness systems are critical for level 2 and level 3 autonomous driving vehicles, right? You want to make sure that the driver is aware of what the vehicle is doing, of the road ahead, that he's able to take back the wheel at any time, right?
Right. So you could take corrective actions if the driver is falling asleep or the eyes are closed or any other reason.
Right. So from basic alerts like sound or lights to stopping the car on the emergency lane, for example, if you see that the driver is not reacting anymore.
Oh, I understand. But I would imagine, again, security is probably front and center in this type of scenarios. Being able to protect the data.
Absolutely.
Is that a concern?
Absolutely. So you want to make sure that this process cannot be tampered with, because in any case you could bypass that sort of mechanisms, or make the system believe that I'm actually aware of what the vehicle is doing, and instead I'm actually hiding what I'm doing by sleeping and
Yes.
And that could be, by the way,
a secure way of storing the information.
Absolutely. The process has to be protected.
Like in almost a closed environment, yes.
Right. Yeah. So thank you, Eduardo. Those demos were really interesting.
Right.
And I think it really highlights how important security is, right? So how can we ensure that we keep this type of system secure?
Right. And this is applicable to any application that, as a manufacturer, you want to deploy on your vehicle, right? It can be a computer vision application, it could be anything else.
Right.
An interesting aspect of this specific demo is that it's running inside a Snap.
So, wait, what is a Snap?
A Snap is a new Linux packaging format using container technology.
Okay.
And Snaps they work across different Linux distributions. It's Ubuntu, Fedora, etc. But they're also portable across different form factors, different hardware revisions, different architectures. So you can use Snaps in your IoT device, in your car, in the cloud. And this goes back to taking those learning from other verticals, from other applications, and bringing the latest information to your specific application.
So how do you guarantee that your Snap can run correctly on a different OS? Do you ensure that in the package you have all the different required libraries?
Mm-hmm. Exactly. So a Snap, by being a containerized packaging format, it bundles an application with all its dependencies.
Okay.
So each application sits in its own sandbox environment,
right?
And it has all the required information and dependencies to be able to function. and only by explicitly granting permissions, a certain application will be able to access the other information on your system. Whether it is a security camera on your IoT device, trying to access the information of your contacts on your device, etc.
Right.
Only if explicitly permitted, you will be able to grant those permissions. And by being in a sandbox environment, we are bringing the standard Linux kernel confinement capabilities, whether this is SecComp, Parmer rules, etc., or C groups. We are bringing the container technology down to devices in the automotive world.
So it's in short, it's a completely encapsulated application that has everything it needs to run correctly, and it's tamper-proof.
Exactly, and it brings with itself certain differences from other container formats, right?
Right.
A big focus around snaps is the ease of development and deployment. So we give the end user an application developer view to what they're trying to do. So you can keep your higher level application information, and all you are required to specify in the snap format is the dependencies required for your application to run. So it's very easy to develop, very easy to deploy, very easy and bulletproof to run.
So in this case, so we tick the box for the application layer, right? How do you ensure that the lower layers are secure?
Right, and another way of phrasing your question is how do you run, or where do you run a snap, your application, right? Can you run that on an underlying secure base? And the answer is yes, because you can run snaps on top of an operating system, a Linux operating system like Ubuntu Core.
Ubuntu Core.
And Ubuntu Core, from the name itself, it may remind you of Ubuntu, of course, and it is standard Ubuntu. It brings the same packages in the same Linux kernel as the standard Ubuntu, the same security fixes, CVE patches.
So you benefit from all of the advantages of Ubuntu Desktop or Ubuntu Server, but in a very small, lightweight form.
Exactly. Ubuntu Core is tailored to your application. The system has a lower footprint than the classic Ubuntu Desktop or Server to make it fit for IoT devices, easy use in automotive world, etc. And the entire architecture of Ubuntu Core is designed in such a way that it is tailored to the requirements and the constraints of the Internet of Things software-defined world, whether that is for devices or for automotive.
Okay. And what about the even lower layer? Like, for example, the kernel. How do you ensure it's secure?
Right. There are, I think, two ways to look at this, right? The Linux kernel itself is the same one across the family of Ubuntu distributions.
Right.
And Ubuntu is well known for the standard review cycle that the Linux kernel goes through all the time, making sure that all the latest CV fixes are available.
Right.
There's always security maintained and patched long term. So we have a reputation for doing that 24/7, whole year long, right? For the past 20 years. But another way to look at the same question is also to run the Linux kernel itself in its own containerized environment. So how do you bring security other than just CV patches and security fixes? How else can you ensure it in the system? An interesting feature of Ubuntu Core is that it is based on snaps. So it is a snap-only edition of the Ubuntu operating system.
So it snaps from the ground up. It's secure by design, and all of the layers are completely protected, right?
Yes. So by being 100% based on snaps, I mean that the kernel itself sits in a snap in its own containerized environment.
Right.
The information specific to the hardware when you're running your application sits in its own snap. The bootloader is in a snap, right? And your user space, higher level application also sits in its own sandbox environment. And this brings a clean separation between the OS and the applications. And you can imagine when you update your device, you can only update the specific component that you want to focus on. So whether that is the kernel, that is the application, etc. There's a clean OS to application separation.
So you're mentioning updates. That's actually, I would say, a key challenge as well in the automotive sector. You want to make sure that you can update safely, securely, all of your fleet without having to recall millions of vehicles and without having to send an engineer to the customer's house, right, to fix this. So what are the solutions to provide this sort of over-the-air update?
Yeah, this is strictly related to the software-defined trend, right? Having an OTA over-the-air capability. It's not just about doing over-the-air updates these days. You also want those updates to be bulletproof and to be transactional, which means that you always want to keep your software running. And this is about reducing the cost of ownership of your device, of your vehicle, etc. You want to reduce the downtime. Right. It is very expensive to send, as you were mentioning, to recall the device or to send an engineer down at the factory floor to fix the hardware that stopped working. And often we see that, especially in different verticals, customers and partners are almost resistant to update their devices or the software on their vehicles.
Because of that risk, right? You don't want to break a vehicle.
Exactly. You don't want to leave it in a broken state, and then you need to send an engineer to fix that. So often they decide not to even update the software, and they're running unpatched Linux kernels, not the latest version of the application, and they are unable to keep up then with the competition if you can't update your.
So how can you guarantee that the update you're going to be sending to the device will not break the device?
Right. The Snap packaging format, and by definition Ubuntu Core being based on snaps, bring a software distribution mechanism that is extensively tested in production environments with a series of characteristics that make it a good fit for embedded world, for industry, for automotive. By that in particular, I'm referring to the Delta transactional rollback functionality of the over-the-air update mechanism of Ubuntu Core and of Snaps. So you can imagine updating your device or your vehicle via an A/B update model, which means that you're preserving the existing version of the data,
the working one,
exactly, on your device, while updating to the latest version. And at the end of the update process, you compare the two, and only if the update is 100% successful, it is shipped on the device. Otherwise, you go back to the previous copy that you were maintaining, the working one.
So you have an automatic rollback to the working one.
Yes, you always revert back to the previously working revision in case of failure. Failure, it could come from a variety of scenarios.
So for example, a corrupted update or a code error.
Yeah, it can really be any potential scenario. And you, in this way, via the rollback functionality, going back to the previous revision, your software-defined anything, your vehicle, is always, the software on it is always the latest working version. So you reduce the downtime and the cost of ownership of the vehicle itself, right?
Very interesting. So I think that you brought a third demo.
Indeed. Shall we take a look? So here we can see a third demo where if I move relatively fast, the application is still able to keep up with my movement. And it's essentially able to almost predict the trajectory that I will follow. And it's just an example of being able to capture the movement of my face, but this could be any other scenario. It could be a pedestrian or other items encountered in the environment. I was thinking automotive, especially with autonomous driving, being able to capture what else is happening is crucial, right?
Absolutely. So when you look at vehicles today with a certain level of AD, you're mostly targeting highways, right? Because it's relatively simple. You have only one or two lanes, the surrounding lanes, let's say. The vehicle can accelerate, decelerate, turn, and potentially change lanes. But you're dealing with a limited number of type of objects, right? Why is it so difficult to have urban autonomous driving? It's because you have so many possibilities and so many different types of objects.
Exponential complexity.
Exactly. It could be a pothole, it could be a person, it could be an animal, etc. And you need to make sure that you can track all of the trajectories of all the surrounding objects.
Movement, not just the contour, the face, the eyes, but the actual movement.
Where is that object going, and is it a risk? Is it a potential obstacle for my vehicle? Because you want to make sure that the vehicle can brake immediately if there's something in front of the vehicle.
Or even preventive, I would assume, with the IML, you can predict where
the trajectory will follow, and then you can act
Right.
accordingly,
If you're able to identify, let's say, bicycle, you know more or less how a bicycle behaves in terms of speed and trajectory. Absolutely. Yeah.
So this comes down to being aware of the surrounding environment, right?
Yes.
We are moving from the first scenario where it's almost inward inside the car, and now instead we are being aware of the rest. It's
right. It's all about the vehicle being aware of its surrounding environment.
Yes.
But the key challenge here is that you want to guarantee that your system behaves very quickly, right? Because it could happen anytime.
So this is essentially just an example of an application you could be running on top of that underlying built-in security that is foundational of Ubuntu core as an operating system, right? It could be almost any application, but here we're showing a scenario where that guaranteed response time to be able to brake for the car, right? You're able to do that within a certain response.
Right, exactly.
So let's talk more about actually this guaranteed response time, which is a key feature that a software vendor must be able to use in automotive.
All right, let's go.
Yes.
Thank you, Bertrand. That was a very interesting demo, and it makes me think, how can you ensure in this type of use cases that a certain process or action is executed in the right timing?
Right. It's all about reducing the latency of your system, right?
Right.
But also about guaranteeing a certain response time.
Exactly.
This is what a real-time Linux can give you, that bounded response time to meet your requirements.
So I hear a lot about real-time. Could you tell me more what exactly it is?
Mm-hmm. Of course, and we recently announced real-time Ubuntu. This is about the preempt-RT patch set being integrated into the Ubuntu operating system. And preempt-RT is just the name of a series of patches that are hosted at the Linux Foundation and that implement a priority scheduler and other real-time mechanisms.
So preempt as in preemptive, right?
Exactly.
So what exactly does preemptive mean in this case?
Sure. So if you think about preemption is at the core of real-time. Without preemption, you can have a process which is nothing more than a program in execution running inside the kernel mode.
What would you say is the key difference between real-time and low latency?
Yes, there are different ways of approaching preemption in the Linux kernel, and in the mainline Linux there are different preemption modes. And you already have what we call, in layman terms, a low latency kernel with the preempt model, right? Preempt-RT is outside the mainline Linux kernel, and it's what brings you that real-time capability. It all comes down essentially to your latency requirements, specific to your application and your use case. There is a trade-off that comes with the real-time kernel. You need to look at your throughput versus latency balance, and only knowing the exact metrics that you need to meet, you should then be able to make the decision. Because real-time does not necessarily mean optimized performance. You need to define performance for your use case, right?
So real-time doesn't always fit with that sort of use cases.
Exactly. And if you think about having latency requirements in the order of seconds and your hardware running multi-gigahertz with a properly tuned CPU, probably you don't need a real-time kernel, right? Low latency would be fine for you. But if the consequences of missing a deadline are very dire, like in the automotive use case and when it comes to safety, if you want a guaranteed response time, then you probably should go with the real-time Linux kernel.
Right. Thank you, Eduardo. That was really interesting. Well, I hope that we helped you understand how real-time and security can help in the automotive industry. And hopefully you've seen also that we are already working on solutions that can fit in these difficult challenges. Thank you so much, Eduardo. That was really great having you, and thank you for all the insights.
Thank you.
We really hope that you've enjoyed this fireside chat on real-time and security and how it fits in this very challenging automotive industry. By now, you've learned about Core, Ubuntu Core, and Snaps, and how they've been built from the ground up with security by design, and also how real-time can fit in certain specific automotive use cases. Thank you for joining, and see you next time.
See you.